Well, good evening and welcome, one and all, to another installment of the Tuesday night lecture series. We are running a winter series here, so we're going to be having talks monthly for the next number of months, and brought to you by the Mid Ulster Amateur Radio Club. So tonight we're joined by Paul. Still, to me, he is still MI1AIB, as that's how he was introduced to me. But it's M1AIB Paul, and based over in England. And he's going to be talking to us about all things radar, air traffic control, and what really happened in the outage of 2023 and who switched off the big machine. Paul, we all know what happened there. So if you're watching us on YouTube, brilliant. Glad to have you with us, sir. Hit a like, hit a follow on our YouTube channel, and it really does make a difference. And Paul, when you're ready, we'll throw it over to you. Maybe you can tell us a wee bit about yourselves. You'll need to unmute yourself there, a wee bit of introduction and everything else. And over to you, or I've got you there now. And yeah, Paul, floor is yours.
Okay, thank you. Well, hopefully you can see the screen. Everyone see the screen okay? The screen sharing is working?
It is indeed, Paul.
Sorry, say again, Dave?
Yep, all working. I see a few thumbs up there, so we're
okay,
all good.
Right, yeah, good. Philip mentioned Dubai there. Briefly, that the picture in the background is actually taken in Dubai by me some years ago. That aircraft now would be ploughing into the terminal building because that's where the current terminal building is on what was that runway. Anyway, so yeah, I'm not sure where to go with this. There's been David's mentioned ILS, radar and things like that. So I'm Paul, M1AIB, as Dave said. I've worked in the aviation industry as an air traffic engineer for 30 odd years, possibly a bit before that in sort of secure comms. So this is kind of a ramble. David asked about ILS in particular, radar. Radar's easy as blip ping, but we'll come to that. Or what is an air traffic engineer? Because a lot of people say, well, what is it? What do you do? And what do we do other than, as has been pointed out, unplug things? So this is me, duty air traffic engineer, Gatwick Airport. This is actually the roof of what they call the new control tower building, which I think is now 40-something years old. And we had some maintenance recently, replacing a motor on the primary radar we have on site. So I had my picture taken while we were up there. So why am I here? Basically, as Dave thought it'd be a good idea to come and give you can't see half of my thing here because of a bit of a chat about ILS, what it is, how it works, which we'll go into a little bit. If you just want to know about ILS, to be honest, there's an awful lot of information out there on the YouTube and all over the place, mostly aimed at pilots for pilot training, but there's some good stuff out there. Wikipedia actually isn't too bad. So I'll hopefully provide some not too technical stuff. As Dave said, ILS now aids air traffic management systems, along with a little bit of insight into why they might be needed. What I am is an ATE, or ATSEP now, air traffic engineer, or airfield engineer, or aerodrome engineer. Ground radio was the RAF name, Trade Group 3, I think they call themselves, or duty engineering officer, depending on who you speak to. Under Europe now, we are air traffic safety electronics personnel, ATSEP. But not much has really changed. It's a harmonised ICAO qualification that you have to have. So we'll go on to what we do. We're not in the habit of unplugging things, contrary to popular opinion on bank holiday Mondays. I personally have a very good alibi. I was on my boat in Leicestershire. We basically, for every piece of equipment that's in place for an air traffic control to use, there's got to be a support system, and we are essentially the front line of that support system, carrying out routine and preventative maintenance and various degrees of reactive repair. At the moment, we're on a bit of a lockdown maintenance-wise because going back to August, NATs in particular are a little bit sensitive at the moment about causing issues operationally. We had another outage on Saturday morning, which you may or may not have heard about. It did make the news, which was maintenance related. So, a bit about why we have to do what we do. So hopefully that just gave you a little bit of a taster of kind of the level of traffic in UK airspace. The links in the links here in the slide to Airspace TV. It's worth a lot. There's quite some good videos there. If you pick the right one, you can actually look at the traffic from the previous 24 hours up to 2 hours ago, at any given time. So yeah, that's worth a lot. Well, that gives you an idea of what air traffic controllers in the UK are doing, and obviously why it's fairly important that they have the systems in place to allow them to do that efficiently, and those are the systems that we look after. So as you can imagine, there's a fair inventory of equipment and systems in place to support that kind of level of operation, and not just within NATS. There is life outside NATS in air traffic control and air traffic engineering. I'm just going to stick basically primarily to a lot of the stuff we have here at Gatwick, just for convenience. So, no prize for guessing where most of the pictures are. Our picture here is actually one of the old equipment rooms in the old control tower building on the 3rd floor here. Used to be the radar room many years ago. So we'll start off with what we're involved in. I had put a lot of that set stuff in here. So we basically have communications, surveillance, navigation, the whole raft of about 5 primary sort of subjects that we have to cover, and equipment groups that we look after. So we're going to starting with communications. Obviously radio, telephone, and data, and more these days is actually IP based, which Philip will love. Does my head in. So we start with radio. We have Park Air radios. These radios, on the left there. They're Parker T6s. They actually rate transmitters and receivers, although they're both T6s. One's a receiver, one's a transmitter. The observant may be able to work out which one's which from some of the indications on the front panel. These are the D radios. They're connected to emergency voice switch in the tower. You'll not see much sign of a telephone. The picture on the right, if you can see a couple of telephones sitting at the bottom of the cabinet there. They're for testing purposes, IP phones. Everything is pretty much done through a central voice communication system, and we have 4 at Gatwick. The red one is the emergency voice switch. The black one is the standard voice switch. The standard switch is actually, although it's 2 separate cabinets, it's actually one large switch split between 2 sides. And these are the 2 cabinets at the new control tower site. One is the main switch, the one on the left, and the standby switch, which is the red display. Sorry, the one on the left is the main switch. The one on the right is the standby switch. I'll get my colours right. Yeah, we use green for the primary and yellow for the secondary. As you can see, there's not a lot to see on this kit. There's a few flashing LEDs, and it's all very integrated and all very IP based these days. We still do have analog connectivity, but that is slowly moving disappearing. Some of the last of the analog connectivity will be disappearing quite soon, actually. This is a typical front panel. This is an engineering position in the control tower. And basically what the controllers have is this, and this gives them access to RT, air ground telephones, and a number of intercoms, and buttons aren't active on that, but you see the big red buttons for the emergency alerting system, which is essentially crash alarm system. The layouts are different depending on roles and what the controllers do, whether it's ground air traffic, ground air delivery or whatever. This particular screen is an engineering screen layout for us. So you can see we've got the VCR supervisors and things like that as direct access buttons. This is an eVCR panel. Basically, this sits hidden away. This is in the old control tower, which is actually redundant now. It's soon going to be all removed and built into a virtual standby tower as a temporary measure, because the state of the building, they've condemned the old VCR. So this is just for convenience. It was an easy one to get to take photographs of. Basically, there are 2 of these, one in the old tower, one in the new tower. And in the event that the main voice switch falls over, they can pull a drawer out, and they have access to this one, which gives them access to pretty much everything they had before. Not quite as much, doesn't have every phone line that they've got on the main switch. But it gives them access to the same radio frequencies and a limited number of direct lines and things like that. Purpose of the eVCR, the emergency, is actually for shutting down, so it's not something they'll use routinely. Everything they do in terms of communications is recorded. Cabinet on the left there, that's the recorder. Again, it's all solid state, it's computers. Everything is computers these days. 2 big servers at the top there dealing with the voice recording, which is all IP now. And the smaller units lower down are actually screen recorders. So all the video screens are also recorded. Screen grab on the right there is just a bit of an example of the engineering monitoring screen that we have that looks after the screen recorder. That's actually not the layout of this one. It's one taken from a manual just for convenience. In terms of supporting all this communications, we've still got some quite old stuff kicking around. So this is the old BT frame room in the new control tower. An awful lot of that copper is actually now redundant, but there's still some there, and anyone knows anything about comms will still see some old fir tree type blocks there. And a lot of that was in regular use until very recently. The old Meridian telephone exchange sitting there is now redundant, and the cabinet on the left there, that's the back of a large rank of private wire circuits, which are again almost now all redundant. And they've been end of life for some years. So Gatwick, like a lot of airports, have been sort of hanging on, and BT have been having to give best level support on stuff that's absolutely outdated and no longer supportable, frankly. But we are moving on. We still have some old modem type stuff, so we still have some circuits X21. We've still got some very old analog muxes there for routing comms across the site. But again, those are all slowly becoming end of life and will be replaced. Some of which in the process of being replaced already. So there's a lot of general comm stuff. You can see on the left there, big old chrome frame, double-sided. That was pretty full of kit when I first arrived nearly 5 years ago. Spent a lot of the last 5 years ripping an awful lot of that out. And as you can see on the right there, obviously in favour of Cat5, Cat6 and fibre optic, supporting all the general comms, up to what we now have, the latest generation of data networks. We have an airfield data network, which has now replaced all the copper in the ground across the airfield for supporting all the nav aids and basically all the cross-site communications within the airport. We have an MPLS system, which Philip would probably understand. It's based on Nokia hardware, and it's probably capable of supporting the internet service for a small country, somewhat of respect for what we need. But it allows us basically to run point-to-point Ethernet and serial links pretty much anywhere on the airfield or within the aerodrome on a very resilient meshed fiber link. The silver trays in the top of the cabinets on the left there, 96 fibers in each one of 144 that have been connected. So still room for expansion. And we're not using huge amounts of those 96. That's just what's being terminated. And that's not the best picture, but that gives you an idea of the mesh network that it's actually supporting. Each one of those squares is a node around the airfield or within the control towers, which is providing connectivity. So now all the radios, all the ILS, all the nav aids, so we've got MET, VHF radios, all that kind of stuff is supported by point-to-point links over this network. Some of them are still serial because the equipment on the end of it is still legacy serial communications. But a lot of it is just Ethernet point-to-point links over this network. And that's been quite a steep learning curve for me, because I'm still old-fashioned copper me. So having to learn my way around this latest state-of-the-art IP-based stuff has been quite a challenge. So that's kind of the comm side. Move on to nav aids. ILS, DME, markers. What we have at Gatwick, we have instrument landing systems, we have DME markers. I have worked, over the years, I've installed markers, NDB, non-directional beacons, VOR, VHF Omni range. They all exist in the wider world. We don't use them at Gatwick. In fact, very few UK aerodromes, can't think of any that have actually still got markers. A few, like Derry, for example, still use NDB. And one or two have VOR on or close to the airfield, although that tends to be more of an en route nav aid, not an aerodrome nav aid. So ILS. Basically, ILS provides the precision guidance down to the runway, depending on the category, down to and along the runway. These two pictures, the one on the left is an installation I did many years ago at Bristol. As far as I'm aware, certainly the gantry is still there, but whether the array has been replaced since then, I don't know. That would have been the late 90s we were doing that. The one on the right, that's actually 08 right localizer here at Gatwick. Taken a couple of weeks ago while we were out about doing our weekly checks. And so that's an element the localizer bit will come to, but the localizer bit provides the azimuth guidance down the runway center line. So they're off the end of the runway on the extended runway center line. The other element, again, one of these pictures is Gatwick, is the glide path that provides the elevation information. That one on the left, I think, is RAF Chivener, one of the RAF replacement sites I did. And the one on the right is the 08 glide path here at Gatwick. You'll notice they're slightly different. 2 antennas on one, 3 antennas on the other. There are 3 key types of glide path, but in terms of what the signal produced in space, they all do much the same thing. As you can see, picture on the left. This is the Dubai one again. That's an array that I installed back in '97, I think. And as I say, that runway now has got the huge international terminal running along its length. The one on the right, that's Gatwick, 08 right. But again, so this one shows how it's on the runway center line. I'm actually basically standing on the runway center line looking up to the runway. You see aircraft taxiing out, and that's providing the azimuth guidance. So this is how it does it. I'm going to keep things very, very simple here. I'll kind of skip through, so I'll give you time to come back if you want to ask questions. Essentially, it's an AM transmitter. In its simplest form, it radiates two audio tones. So by a fairly complex means of, I'll tell you what we'll do. If I can. Right, so hopefully now you can see my Adobe screen. Thumbs up if you can see this screen that says Normark ILS, Normark 7000 ILS. This is just I'm going to get very quickly through this. This is the a training manual. It talks about ILS principles and equipment theory. If you Google it, you can find this online. If you want a copy of it to read through, you're welcome to a copy I can send you. It deals with it simply, so it's quite a useful diagram, this, which basically shows that the principle where you've essentially got the localizer giving left and right, the glide path giving elevation. It shows marker beacons. We don't use marker beacons anymore. They tend to be distant measuring equipment, but the theory behind it is really quite complex. We have different categories of ILS, from non-precision through to Cat 3C, which is I think we are Cat 3C here at Gatwick, which is essentially down to the ground and along the runway, typically to within 600 meters of the opposite end of the runway as they land. So complete zero visibility, hands-off, auto-coupled approaches. The way it does it, it starts now getting this. So let's talk about theory. So it's basically signals which mix in space, and it relies on phase relationships and amplitude relationships and some very, very complicated maths. I don't pretend to remember or know half of this maths, because even for installing it and commissioning it, I don't need to know. And certainly for maintaining it, I don't need to know. So if you want to really get into the theory, there's all sorts of really in-depth stuff there that you're welcome to have a copy of. Some of these waveforms we see routinely on our maintenance bets. So we are very much simplifying on the right page then, the basis. So this is what it does. Basically, what it does, it radiates an amplitude modulated signal in a fairly complex phase and amplitude array, which essentially gives you a 90 hertz and a 150 hertz audio tone. You can hear it just about on a handheld. It's a little more complex than that. What it does is it modulates the tones to a certain level, and where the difference between the modulation depths is zero, if you've done it right, is when you're on center line. For a Cat 3, that's within a meter or so of center line. So it's quite an accurate system at Cat 3. It does it with two transmitters on the higher level systems, like the one we have here at Gatwick. We have separate course and clearance. So what it does, it has what they call a clearance transmitter, which adds lots of 90 and lots of 150 hertz. Those are the two audio tones, fly left, fly right, to fill in gaps where you've got reflections and things like that. So that is in essence what the localizer does. The glide path does the same thing, but on its side. Difference with the glide path is you only have essentially half an aerial. You'll notice on this graphic it shows aerial below the ground. So glide path gets a bit more complicated with the mathematics because you're relying on not only the direct radiated signal, but also the inverted reflection of that signal and how they mix in space to give you a zero DDM, they call it, difference in depth of modulation, which aligns with 3 degrees, which is essentially 50 feet at threshold, 50-foot crossing height. It can actually be as high as between 45 and 55. There are tolerances on that, and that obviously can depend on the aircraft type as well. So going back to this graphic, which you've seen, basically shows you the components. Localizer sits at the end of the runway. This diagram, a lot of the diagrams still show a bit sticking off the back, which is what they call back beam. Modern ILS does not have back beam. It hasn't been allowed to have back beam for some years. But back in the day of the early ones, where the antenna arrays were quite basic dipole arrays, they had quite a noticeable what they call back beam, which could be used. You have the glide path, which is typically about 300 meters back from the landing threshold. That's usually where the distance measuring equipment is also located, if it's a single ILS, or if it's a dual ILS, such as at Derry, for example, and here. It can also be a single DME at the runway midpoint, which is what we have here. So we have a single DME, radiates omnidirectionally, and it's positioned such that the range to threshold is 0. To both thresholds for approaching traffic. Markers are the old way of doing it, outer markers, middle markers, inner markers, and you can also have NDBs on approaches helping to give guidance information. Certainly, that's very unusual in the UK. I don't know if any have got NDB approaches. So that's your basic, what the ILS is, what it does. It's specified to give a certain level of coverage. With a localizer, it's quite wide, plus or minus 35 degrees out to 10 nautical miles, plus or minus 10 degrees out to 18 nautical miles. All these systems are checked with a flight check aircraft when we commission them, and routinely then with 6 monthly and annual flight checks. And essentially what they do, and this is where the PowerPoint fell apart a bit. I had some other graphics which showed a bit more about from an aircraft's point of view. But you have the very basic crosshair here. So essentially a pilot has an indicator, which can be as simple as a crosshair as indicated, but these days obviously with glass cockpits it's a little bit more technical. It's overlaid on various other information as well. And they basically follow the crosshair. If the crosshair moves off to the left, they basically steer to the left. And it brings the crosshair back in the middle, and likewise, if it moves up, they pull up. And that's essentially the detected audio signal, designed to give them a flag current of 150 microamps full scale deflection. And that's essentially what they do. This is an ILS cabinet. This is one of the ones from Gatwick. Again, no surprises. This is actually a glide path cabinet. It's quite compact these days. Most of what happens in there happens in the big power amp modules at the bottom there. You see the 4 big modules at the bottom, 2 coarse, 2 clearance transmitters. In the behind the covers at the top there, and you see the motherboard at the back, we have the synthesizers which produce the basic RF and the monitoring functionality, and the control functionality in the middle, the local control functionality in the middle, which obviously is all remoted back to our main monitoring area. In terms of antenna distribution, this is the glide path antenna distribution and monitor recombining on the right. What there is behind this panel is basically cables and line stretchers and attenuators. So carrier and sideband signals are fed into this unit from the cabinet. They are distributed to the three antennas. These three phases, the top three, are the sort of last in line to each antenna. Sorry, the three phases at the bottom are the last in line to each antenna. And then we have power dividers and phasers, etc. These are used during commissioning. We don't touch these as maintenance now, so I haven't played with one of these for a long time, because now we just do maintenance. And unless we get an antenna failure and have to do a recommissioning, we'll not touch this. The one on the right is the monitor recombining unit. So what that then does is take a small sample of signal directly from each antenna and puts it back through this unit, which reconstitutes it back into carrier and sideband, which goes back into the cabinet for monitoring the radiated signal. There's also a near field monitor. So there's an antenna about 60 meters in front of the main radiating antenna, near field antenna, which sits at a certain phase point for monitoring. The localizer, bit bigger. So as you can see, we've got two big silver boxes there. One of those is the distribution unit. One is the recombining unit. The array we have here at Gatwick, they're both 24 element arrays. So each of those antennas is a log periodic dipole. There's 24 of them. These are going to be replaced soon, and the replacements will have 32 antennas, because of the need to mitigate against the A380 causing structural problems to the parallel runway when they expand the runways. In terms of monitoring, I mentioned near field monitoring. The antenna on the right hand picture there, the one that's sticking up in the air there on the center line, that's the far field monitor. So for category 2 and 3, we have to monitor the radiated signal at the far end of the runway, not just locally. So this is a completely independent monitor receiver, completely independent from the actual transmitter. It sits in the opposite localizer. So we're at 08 localizer in this picture. That antenna is receiving from 26 localizer. And that's received on this box in the 08 shelter. And you can see we have a display on the front there, so we can look at that, and we're seeing the DDM, which I spoke about, difference in depth of modulation. We're also seeing the sum of the depth of the modulation. So the overall modulation depth is 40% for a localizer. So 20% equally for each of the two tones, 90 and 150. And when they're perfectly balanced, the DDM should read 0. That's reading, minus 0.14%, about a microamp, just over a microamp, which is, it sits around that most of the time. I think the limit is 4 microamps for Cat 3. So, and again, this information is actually fed back into our monitoring center back in the old control tower, and recorded and logged. So that's ILS. Kind of skipped through it fairly rapidly. I know, wasn't sure what the time restraints were. Any sort of questions about ILS generally?
Paul, what came first? Your amateur radio or your ILS radar and everything else? Were you an amateur first who then got into electronics and ILS, or an amateur and radar and everything else? Or were you an electronics person who got into amateur radio? You're on mute there, Paul.
You muted me. Sorry. This came first by accident. I was always interested in amateur radio because my grandfather worked for Marconi, although he passed when I was 12. And my father worked for Honeywell and IBM and various others over the years. So there was always an interest in amateur radio. But I never really got around to doing it until I was working in the aviation industry, just by accident, really. Before doing this, I'd worked in secure comms. I'd worked as a contractor, basically as a wireman. So I had worked, funny enough, at RAF stations on some secure comms stuff and various other environments doing fiber optics and networking, etc. So amateur radio just came along at a convenient time, sort of came along not long after I started in this industry, to enable me to go to Newbury College and do the RAE, basically.
What do you do with them antennas when you decommission them, Paul?
They get recycled, they get weed, as it were. In the past, when I've done replacements, we've just had, we've had to pay outside companies to come in with specialist skips that we just trash them into skips. A lot of the antenna framework, that's all aluminium. So if we can, we'll tend to weigh that in. It's quite good beer money for all that aluminium. So yeah, that obviously when it comes to replacement time at Gatwick over the next couple of years, whoever wins the contract, it'll be down to them to dispose of it legally as part of the contract.
I see Davey had the hand up there. Davey, if you want to unmute yourself, or do you want me to unmute there? And go ahead. There you go.
Yeah. Can you hear me?
Hi, David.
Yeah. Hi, Paul. Davey M1AIB. I just wanted to know, were you ever down at the Aviation Society here at Lisburn?
I did one visit down there. Yeah.
Do you remember did you go into the old radio room?
Yes, vaguely. It was a long time ago. I've slept a bit since then, David. It was a while ago. I do vaguely remember the old radio room, actually. Yeah.
I have a photograph here. I don't know why you can see it or not. Can you?
Not really. No.
I can't see. It's old radar equipment from Belfast International.
I probably would have seen it. Yeah.
I picked it out, so that I don't know why you can see it or not. Can you see it?
Not because I've only got you. There's a little tiny thumbnail in the corner, I'm afraid. So.
All right. Can anybody else see it? No. I can't hear anybody else.
No.
Dave? No.
If you bring it closer to your camera, Davey, I might be able to. I can see there's big racks of things there.
Yeah. That's the old radar equipment from Belfast International.
Yeah, it's the old AR1 or AR15 stuff from the look of it.
Yeah. That whenever that came into the Aviation Society, whenever we were building the radio room, that had maybe 50 or 60 blue, red, yellow, orange lights. So the old glass bulb lights.
Yeah.
And I was asked to put a 12-volt battery in the inside and wire up all the lights to the switches so that the kids could play whenever they come in do. That was fun. That was fun, Paul.
I can imagine.
I thought I'd just show you that.
I've not worked on a huge amount of radar. We've done some old second-hand installs. Company I worked for, we'd do stupid things like buy an old AR-15 from an RAF station and put it in at places like Cambridge, which subsequently got replaced. So there was a lot of end-of-life stuff. Or the RAF was still had some old radar kit, and so places like where else were we at? Cambridge and Broughton. The British Aerospace, we installed second-hand radars. In fact, Cambridge's ILS, the first ILS they had, I put that in, and we actually took that out of knock. We took an old ILS out of knock over in Ireland there, I bought it back in the back of a transit van and a trailer, and we installed it in Cambridge, and that was only actually replaced again relatively recently. So in answer to your question, Philip, some kit actually just historically has been reused and relocated, but these days not so much. Yeah.
Just a quick one, if I may, Paul.
Yeah.
With the ever increasing efficiency of ADS-B,
Yeah.
The relevancy of radar in future, do you envisage that being made redundant?
Yeah, it's still quite important. I'm going to come on. I mean, I've got some stuff in here on surveillance, so I was going to go on to that. So, if we carry on, the next bit I've got is about surveillance.
Okay, thank you.
And what we have, but ADS-B is forming more and more. The ADS-B part itself, though, is obviously you're relying on the broadcast from the aircraft, as opposed to interrogations or Mode S transponders. But it is a factor. We do use it. We use it already. So I mentioned VOR as one of the other nav aids that we don't really deal with, and it's one of the things I used to install many moons ago, and that's just a picture of a Doppler VOR. Not sure where it is. I just grabbed it off the internet. You installed one or two of those over the years, and that's actually 48 sideband antennas which radiate in pairs, which are rotated electronically around a central carrier antenna. And it's the kind of Doppler relation between those that gives you the azimuth from the beacon. So there's still a few around in the UK. So if we move on to surveillance, we're talking primary radar. We have one primary radar here at Gatwick. Secondary radar we don't really have, and then we have multilateration or MLAT, which is multi-static dependent surveillance, or now they're changing it to collaborative surveillance. And then of course ADS, you've got your ADS-B, FR24, etc. This is our primary radar. Will this work? That's it running just above my head. It's quite an impressive beast up close. It's 21 foot long, that antenna, and it's spinning at 60 RPM. Suffice to say, this is obviously under control conditions because we've just done the motor replacement. That's what the raw picture looks like inside. That's not what controllers see. This is what we see on the engineering console for that radar. That's me zooming it out a wee bit. And you'll see it's pretty much limited coverage-wise to the perimeter of the airport. That particular radar will work out to about 40 miles if we wanted it to, but we use it in such a way that the range is limited to pretty much within the perimeter of the airfield. But you can see, we can see quite small targets moving around the airfield, vehicles and such like. One of the benefits of obviously primary radar is you only need the signal to reflect off of things. And they did actually have an incident at Gatwick some years ago where someone jumped the fence and was running across the airfield, and they actually picked that up, and the person was seen on the primary radar. And obviously ADS-B and any of the others wouldn't have seen that. So there's still a value for primary radar. What we then add to it with multilateration. So we have currently an MDS system. Anyone who's been to Gatwick or knows Gatwick will probably recognise this as Gatwick anyway. But what we have is you see these labels dotted around the place: RU14, RU3, RU2, RU7. Some of them are red, some of them are blue. These are basically mostly passive receivers. So what they do is they sit there and they listen to the transponder replies from the aircraft and vehicles that are moving around on the airfield. They're based on time difference of arrival, so we have what we call two reference transmitters. They just sit there pinging a time reference every second, and we have a number of the RU units have a transmitter in them also, so they also ping their position. All that lot combined into a system gives us a means to track anything with a transponder, as well as listen to ADS-B broadcasts. And that gives us this picture. This is a raw picture for that system. It's a bit cluttered, and you've got a mixture in there of ADS-B and secondary replies. I can't remember which colour's which, but each of those returns has the ADS-B and the transponder return, and where we've got them in the database, the tags on them, so you can see call signs. You can see call signs there from aircraft, not just registrations. You can see vehicle names there, like Leader 3 at the right hand end there, down near Pier 2. That's not what the controllers see. So this is, in terms of secondary radar, the cabinet on the left there, we've got, again, you'll notice it's all IP connectivity these days. Cabinet on the left there, there's 3 boxes which are Ricky's, and they are our external radar interfaces. So we take 3 feeds in from Gatwick 10, which is actually visible from the airfield, just south of the runway, and Pease Pottage and Bovingdon, which are all 10 centimetre area surveillance radars, all with secondary. Those feeds come in here. They're recorded as they enter the building, and they go into our surveillance data processing system. Cabinets on the right there, that's actually the 2 transmitters for the surface movement radar, which is the one on the roof of the tower. You can see the waveguide is quite small. It's around 10 gig frequency. There's quite a small waveguide. And the magnetrons are size of a small coffee cup, not big. I meant to bring one in actually to an old one in to show you, but I forgot. And then all that gets basically what they call fused. So this is what they call it's a fusion-based system. So this is what they call ASMGCS, aerodrome surface movement ground control system. Basically allows the controllers the ground controllers to see what's going on, who's where and where. Blue labels are departures, brown labels are incoming. Not a lot happening on this particular screen. Little grey box at the top there, that's a countdown, so you can see Easy 59 Whiskey Foxtrot is actually 60 seconds out on the approach, and that helps the controllers when they're lining them up and getting them off. Is there any vehicles there? Can't see any vehicles on that particular view, but this is a fairly dynamic map. You can see the red areas they've got on there. Controllers can put exclusion areas and closed off areas, and they have all the stands and things like that. You can see, if you look around, you can see some little yellow reflections and little blue patches. They're actually the primary returns, which are also fed into this system. And the other one they have, this is more for the air controllers. This is the air traffic monitor. This one is where we take the information primarily from the area radars that we take in externally. So all the information here is what's coming in from the Gatwick, Bovingdon, and Pease Pottage radars. They tend to use one only at a time. This picture will show a sort of fusion of all of them, depending on how far they zoom out. But when they zoom in, they'll tend to have Gatwick 10 as selected as the primary source for the secondary radar. And pretty much everything on there actually is heading in for Gatwick. An overflying Ryanair. So everything that's got a little down arrow is obviously descending. Where it's got a KK, that means it's heading into Gatwick. What's interesting on this, you'll notice, you may notice the blue line along the top is the coast. So we have to kind of get used to the maps being south at the top, because that's the way the controllers sit and look out the window. So that kind of catches us out occasionally. This is one of the new RUs. There's a new system going in, a collaborative surveillance system. So our MDS system is currently under, probably one of the oldest within the NATS estate. It's currently being updated. The new system will be going live early-ish next year. This is 2 of the new remote units that are in a cabinet in the control tower. Much smaller than the old ones. Well, I haven't got any pictures of the old ones. So that kind of covers the surveillance we have at Gatwick. Again, I'd hope to put a bit more in, but I had a bit of a disaster earlier on when the PowerPoint thing bombed out on me, and then it dumped me back to a recovered version of a lot less than I'd got. So, sorry about that. So that's the surveillance side of it. We'll just move on. So as I say, I've just been throwing this together with loads of pictures. So we haven't. There's meteorology, monitoring, generally operational stuff. So I've just thrown a load of pictures in. This is a raw view of the SAMOS system, which takes all the temperature, humidity, pressures, wind speed, runway data, which they get manually. There's guys that go out on the runway and actually physically assess runway conditions. And this is the raw data. The controllers have this available to look at. That's not what they generally look at. We'll come to that. This is cloud height. We have 2 kilometers and visibility, MET visibility. Again, these are the raw displays. The controllers have access to look at this if they need to. Generally, they don't. They've got another system which kind of collates it all, shows it all together. This is useful for us. We can see if there's been any comms dropouts. You see a little black dot instead of the white dots where it's visibility. You see a black dot along the bottom line because it's had no data. And you see when this picture was taken, I think it was raining. It's saying 0 zeros along the bottom. No, can't remember. I've got one of the pictures that actually shows you can show that it was actually raining. I took the picture because the weather sensors actually have capacitive sensors, so that you actually get, it will give you the present weather, including rain. We have runway visual range is another instrument. This is quite a new one, instrumented runway visual range. Alistair could tell you all sorts of stories about Derry, about having to send a fire tender around to park on the end of the runway, and they count runway light fittings. And from that they've got a table and they'll come up with a runway visual range, and it's that range, not what you think you can see, which determines the category of approaches and landings and whether an aircraft can actually land or not. Gatwick obviously not an issue, it's Cat 3C, but places like Derry, if it gets down too bad, they can't land. This does it all for us electronically, and it logs it, and this is raw data as well as the graphs. But again, what we then give the controllers is a simplified issue of that. This is the system we can use to monitor it and maintain it. What the controllers generally see is this. This is a system called ADIS. It's a very, very old system. Again, it's one of those that's actually due for replacement within the next year or so. So what they have is the wind instrumentation, the temperature, humidity, all of that stuff, the SAMOS information. That's all collated onto this main page on the left. So they have wind speed and direction for each of the runways. Obviously, the runway that's in use is the bigger of the displays. They have the ATIS letter. We broadcast the ATIS, which is a voice transmission on a frequency specifically, giving arrival and departure information, telling aircraft who to call first on departing, whether delivery is open or not, whether ground is open or not. Tells them what the basic current weather conditions are, temperatures, humidities, etc. Data on the bottom there is the TAF, which is one of the data streams we get from the AFTN, which is a fixed telecommunication network specifically for the aviation world. That's actually a forecast for Gatwick, which is just available to controllers. The box there where it says 26 left, U3 and PS, that's actually the IRVR. So what we've got is the big screen with lots of data on it. What the controller's got is that, and that's all they need. And if the visibility is less than perfect sight, what you get in there is figures telling them the runway visual range in meters, and you get plus or minus figures if there's trends with it. ILS U3 means the ILS is available category 3. Unlimited, essentially unlimited category 3. If we were doing maintenance on it or had elements of it out of service, that might show category 1. We tend not to do that. It's either out of service or it's category 3, and obviously the runway in use, etc. The screen on the right, that's an overview of the status of various bits of equipment. This is the one that's in the engineering room. This is a big TV screen we have up on the wall. This tells us there's lots of blue boxes you see in there. There's a lot of kit on here that's been removed over the last 5 years, so all the old status has just been blanked off. But we have basically the far field monitors, DME, IRVR, nav aids, ILS cat change, tells us if there's an issue with the ILS. A lot of these CT3s and VC1, they're all UPSs. The old control tower has lots of individual UPSs kicking around the place, and historically they all had alarm outputs into this system. Air traffic have kind of a more of a summary of this. This is basically where we do it all from. That's our day office. That's the engineering monitoring center, they call it. I've not got pictures of the racks actually. You can see through the window the racks on the left. You can actually see one of the contingency wind displays, or those racks have probably been in there since the building was put together. They're the very old generation steel cabinets, and a lot of that's being replaced at the moment. But that's basically, we have access to pretty much all the systems from a monitoring and control point of view from within that room on the various screens, and we have quite a clever matrix system in place, which means all the PCs and clients are all stashed away in cabinets, and we have console units, so we can actually call up on any of these screens various different systems. This goes back to the MDS system. This is more the kind of thing that the controllers would use. You see on the right hand side, they've got a different window open, so there's whole rafts and rafts of information that they can call on within this system for basically stand information and departure, standard approach routes and emergency procedures, all sorts of stuff. And that's basically as far as I got. So, any questions on anything else? I've got a whole load of photographs I can sort of zip through if there's anything else. That's as far as I've got. That's very much a very quick kind of cook's tour of what I do and what we look after and what our day job is at Gatwick, really.
It's all very interesting, Paul, I must say, and it's sort of a wee sneak peek into behind the scenes and how
it's very difficult to try and condense so much into such a short session, really.
In layman's terms, Paul, I always sort of presumed it's a guy sitting in a room with headphones on and go, right, your turn to land, your turn to land, right, don't you crash, your turn to land. And
From a
obviously,
control point of view, it is that.
but obviously, there's technology behind that
Yeah.
that makes it look simple, you know, and you sort of
We
forget about
are.
these engineers.
I mean, we are the new the CSS system, the new multilateration system that's going in. It has some very innovative technology behind it. That's already feeding data into Swanick as part of a trial for what they call intelligent approach. So ultimately, the display system that the controllers use for for their situational awareness, and this will be happening at Swanick. What we don't do at Gatwick is radar control. All the radar control is done at Swanick.
Yeah.
At CTC, at Swanick or Whiteley. So our controllers deal with the aircraft from 6 miles, maybe a bit further. Can't remember. So they only deal a bit like Heathrow.
Yeah.
Heathrow's the same. So the tower controller is basically they're handed the aircraft. I mean, I know at Heathrow, I think they're basically told to call. They're given clearance to 4DME, and then they call the tower. So that's 4 miles from touchdown, and then they call the tower, and then the tower will just clear them or not.
Yeah.
And then
Yeah.
controller, and they'll land and they'll say right ground on whatever. And it's much the same at Gatwick. However, Heathrow's twin runways, Gatwick is single runway. Gatwick at its highest capacity they're at the point where at the max they can probably, I think it's about 54 movements per hour. When they're running at that level, go arounds become quite common.
Yes.
I'm sitting here, you can't really hear it. I'm sitting here literally 500 meters south of the extended runway center line for the 26 approach. So I can see them really close up when they're on, or when they're departing on 08, because they're airborne a lot further up the runway. They're all over the place. But on the approach, I see them every time they're there, 500 meters away. And you know when they're going around because you hear it.
Yeah.
And you'll suddenly hear the engines spooling up, and off they'll go, and they'll go around. So in the summer, it's surprising how often you hear that. So a lot of the work that's happening at the moment is about improving that efficiency. So what will happen is the approach systems will actually pick out the aircraft, and based on timings and various other things, that will tell the controllers at Swanick which aircraft to give the approach next. And that's that last bit. In terms of the final efficiency then on the ground here at Gatwick, there is a plan to move the northern runway. So at the moment, the runways are too close together to run both runways simultaneously.
Okay.
So there is a plan to change that such that ultimately they will be able to land traffic on the main runway, on the instrument runway, whilst traffic is departing on the northern runway. But that's a year or 3 off yet. But that's kind of the way things are moving. And that's what they're going to have to do to get to the magic 60 per hour.
Yeah. Does anyone have any questions or anything? Any calls, comments, as they say? Feel free. Go ahead, Jeff.
I'd like to ask. On top of the tower, or it seems like on top of the tower at Heathrow, there was an enormous radar dish. Looks like an egg whisk or fly whisk. Was that just for ground operations, or was that for sort of general surveillance all round?
You're talking about the big one that used to be fairly close to the entrance to Heathrow. That was the old.
The one there was a big one up on the tower, or very close to the tower. They called it the egg whisk, but I mean it was enormous. I'm talking a few years ago, mate.
Yeah, that big old one is actually now on the ground at Shoreham, not Shoreham, at Port Solent.
Oh right.
Down at Fareham. It's been installed down there for training, apparently. That would have been the area. That would have been the area radar, basically.
What, for just the whole of the ground, or
no, that would have been the area approach radar. So the
right.
ground radar is a relatively new technology, and as you've seen from the video, it's spinning at quite a high rate. Surveillance radar spins at 15 RPM, so you get 4 sweeps. You get a sweep every 4 seconds. Sorry, whereas the ground movement is every second is a sweep. But yeah, that was the old radar. I think it did have the secondary on top of it at the time. So if you see the big dishes, that's the primary, and then if you see like the flat panel on top of that, that's the secondary antenna.
Okay, right.
For the SSR response.
Out further out, near Perry Oaks or whatever at Heathrow, there used to be, and this is going back a long time, some enormous rotating antennas, which were radar antennas. I always wondered what they were for, whether they were for ground or air. They were long, very long ones, sort of semicircular with a like a hook up at the front.
Right. I would have said again, they would have been air surveillance. Ground radar tends to be high up and looking down. So the reason why the surface movement radar is on top of the tower at Gatwick is because it basically it's actually set to look downwards, and that's how the range is controlled as well. Not just by masking the map, but also you actually control the range by pointing it down. So you can't really see it on that, but that antenna, the way that particular antenna, the radiation pattern from it is essentially looking down.
Right. Okay. I just know that big antenna, when it was first installed, upset a lot of taxi drivers because their key fobs didn't work.
Andrew, you were going to ask a wee question. I seen you just unmuted at the same time as Jeff. Go ahead.
Thanks, Dave. No, it's incredible the interaction or the integration between the radio hardware and software. And I just was sort of curious about what sort of companies tend to be behind that or specialize in that, and is it sort of universal, or is it around the world kind of thing?
There are. I'm not going to comment on the voice, what we call the voice switch, which is like the central integrated bit which does all the telephone, radio, and all of that. What we have here is an Italian one. That's all I'm going to say. Other than it's the only one in the UK, which with hindsight wasn't the best plan in the world. Having said that, we have got issues with it, but it does its thing. Generally speaking, there are a number of companies. Most people have heard of Rohde & Schwarz because of their test equipment. So Rohde & Schwarz are one of the big players worldwide. Honeywell. Company in Austria called Frequentis, who are well known. So it's kind of a worldwide industry, but it's actually quite small. So most people are known. There's companies like Thales that are part of, that have sort of eaten up various other companies. Like Racal used to be around. Racal Avionics no longer exists, but they used to do VOR beacons and ILS systems and stuff like that. Companies in the States. There are other companies around, but yeah, there's probably maybe half a dozen key companies that are fairly well known around the world, but there are others. And obviously there's Russian companies, there's Chinese companies that manufacture all of this stuff. But there are, I think, most within the UK, it'll be people like Rohde & Schwarz and Frequentis for a lot of the general voice comm stuff. Radios, there's Jotron, Norwegian or Finnish company that do VHF radios, which I've used a lot over the years, and they're quite well known. You've got Park Air, which is actually part of Northrop Grumman ultimately. Also the same, it's part of all Indra systems now. So we have The display processing system is an Indra system. The transmitters, receivers are Indra, Park Air Indra. So they're all part of the same kind of group and parentage. So yeah, there's a few sort of lesser known ones. There's other brands as well, Australia, New Zealand, but they're most of them are fairly well known, pretty much worldwide.
Paul,
Fantastic. Thanks. Very interesting.
Yeah, absolutely. A great insight into the engineering works of what might seem, or we take it for granted. We get on a plane, put the seatbelt on, and go somewhere, but never actually stop to think of the work that keeps the planes flying and everything else.
I have to say, unfortunately, the one issue we have really is it's very easy for airlines to blame air traffic whenever there's a problem. Oh, it's an air traffic problem. I do know of an incident where a colleague of mine many years ago was at Hong Kong, the old Hong Kong, and he was waiting to board a flight, and he worked in air traffic. He knew the controllers there, so he heard an announcement that the flight had been delayed because of air traffic controllers, and he could see the engineers out working on the aircraft with all the engine cowlings open. So he actually publicly berated the agent for saying, "Look, come here and tell did air traffic tell you to go and work on that engine? No, they didn't. So tell us the truth." So the aircraft had gone tech. That was the problem. But I think that the modern technology is kind of it has a two-edged sword, if you like. There's a couple of things. Back in the old days, we were quite often regularly tinkering with stuff because it would, it worked, but maintenance was far more regular, and it was actually screwdrivers and tweaking things, actually going in and adjusting pots and, taking measurements. Now it's all PC based. And so much built-in test equipment and so much intelligence in stuff that our primary role now is to literally sit twiddling our thumbs waiting for something to go wrong. We have a certain level of routine preventative maintenance that we have to do. But on the whole, things work very well. The problem with that is you get all these very high-tech systems come along, and we go on these training courses. And I'm a bit of a dinosaur when it comes to what I've worked on over the years. I've worked on some pretty archaic stuff over the years, and come from way pre-Ethernet and everything else. And now I'm having to relearn. I mean, I worked in networking in the early days, and it's quite funny because I've attended training courses now based on stuff that's all around IP, everything being Ethernet and IP. And one of the courses I did, they started talking about the history of networking. And the guy that was teaching it started talking about stuff that Philip will probably remember, token ring and twin axe cable, and way back in the day, IBM, the IBM stuff. And the guy was dumbfounded and said, "Yeah, I remember installing that. I remember installing all of that." And the guy, he said, "I'm not even old enough to remember what it looks like." He knows of it; it's part of the history, but that's so. The moving forward into the modern IP world and everything going via IP and everything else, it's been a struggle. It's a challenge. It doesn't scare me, but there's still quite a lot of having to play with command line stuff within Linux as well. I have a colleague who just can't. He just doesn't like it. He hates it. Can't do it. Doesn't want to do it. It scares the shit out of him. But it's the modern world. But the problem is, it's generally so reliable that when it does fall over, it's like, oh, what do I have to do about this? Because it's been that long. I mean, so the competency and currency thing we have to go through now is more and more important. That's why we have test systems. So we don't just have that whole SDPS system for all the radar displays. We have another separate system beside that, smaller version, purely for test and training. This ADN network, which is multiple millions in excess of 10, I believe, certainly multiple millions of pounds for this airfield data network, which, as I say, could literally support the ISP services for a small country. There is a separate test and reference system which we can use for training and testing. The multi-laceration system, even the old one, there is a separate test system which we can use for training. So the competency in currency becomes quite important, because as you move forward, the kit does become so reliable that when it does fall over, it can be a bit of a struggle. Now, I can't comment on what happened in August. I know some of what happened in August. I will probably never know the absolute detail. What I do know, that Michael O'Leary was a little bit out of order the way he was banging off Nats about their engineers sitting at home drinking coffee when they should have been at work on a bank holiday and all this, that, and the other. There was a process that was followed, and the process took too long. But it was a 1 in 15 million thing. But yeah, there are questions to be answered, and I suspect Nats will end up paying something for that. But
every day's a school day, Paul.
That will never happen again. It's one of the stupid things that all the systems external to the bit that fell over have things in place to stop that actually happening. So somehow one of those external systems managed to let something through, which the internal system said, no, don't like it. And the key problem was, instead of going, no, don't like that, spit it out for someone to check, they went, no, don't like that, switch off. Which is its safe mode. And unfortunately, so the standby system went live immediately, but the first thing it did was then have to try and deal with the same error, and went, no, don't like that, switched off.
Like us all sometimes.
And then,
typical
kicks off, which takes time. So
Philip's sitting there patiently holding both hands up now. So we'll let Philip ask his question, and then we'll begin.
No, I didn't unplug it, Philip. No.
Somebody plugged in their phone charger. No, it's typical computers. They just fail, and even backup systems fail. But never.
Well, we had. I don't know if any of you see anything in the news over the weekend.
No, I didn't catch anything. But here,
it was local to Gatwick. We had an issue Saturday morning.
You fell asleep at the screen.
I was off. No, again, I was not at work.
I'm jesting. Paul, earlier on, you kept mentioning fusion. I thought it was the whole radio system's working on Yaesu, but never mind that. The question I wanted to ask was, you mentioned the magic 60. I take it that is 60 flights in 60 minutes, so that'd be one per minute, right?
Yeah.
Which is still a bit behind Heathrow.
Yeah, well, Heathrow are down to about 40-45 second separation.
Yeah.
But that's because Heathrow can arrive and depart at the same time because the runways are far enough apart.
I remember sitting in a hotel just behind the runway at Heathrow. That was several years ago. And I just sat out in the car park for hours. And you just looked up at the sky and seen all these lights lining up. It was amazing. But as Dave said earlier, the amount of technology that is behind all that, as Dave says, we jump in a plane, we stick on our seatbelt and think, why haven't they started moving that?
Yeah. I didn't touch on the fact we have a number of interfaces direct with Gatwick Airport themselves. So there's information coming in about stand allocation, so that we interface with. So what I didn't point out on one of those radar pictures was on the inbound, there was a little number. That's actually the stand number that's been allocated. That's done by the airfield. That's done by airfield ops, by the apron people, not air traffic. So you've got that whole Gatwick, the airport ops operation side going on. And there's a lot of sort of data interchange between the various systems on that as well, stand allocation and stuff like that.
Brilliant.
So yeah, it can it can get and the coordination, of course, with the centre here. So we don't tend to define which runway they operate from. Obviously, the weather is the primary dictator for which runway they operate on. but when the wind is such they could do either, it's essentially Heathrow stroke Swanwick, which tell us which runway to operate on to basically.
What did you say the runway? Sorry, what did you say the runways were called, Paul? 8 and what?
We're 26 left and 08 right is the instrument runways.
That doesn't calculate the 360. So a runway's not normally numbered like 26 would be 260 degrees and 8 would be 80 degrees.
Yeah, depending on which way they're pointing on the compass.
I thought that's the way it worked, and it normally adds up to 360. But maybe I'm.
It's based on it. It's based on 8. It's based on if you take 8 from 26, you'll get 18. Get 180.
Right. So it works. It does work on that sort of thing,
yeah.
But it works on
it's a rounded up or down figure to the nearest 5 degrees based on the actual runway magnetic heading. So runway headings can change.
Oh, there you go, Paul. Thanks very much for joining us this evening and kicking off.
Very welcome.
Our winter series. It definitely has been interesting and learning a wee bit about the background works of ILS and airports and runways and radars and everything else and antenna arrays and how planes actually know when they're coming towards the ground in the center of the runway and everything else. So thanks very much. Obviously we'll hang fire a few days so we get the non-disclosure documents signed and everything else, Paul.
Yeah, no, I just need to run through that presentation quickly with my boss at work just to make sure he's fairly happy with it. But I don't think there's anything in there that isn't public domain anyway.
Yeah, no worries at all. Do appreciate it, and feel free, obviously, to tune in next month as well. We'll be going for another few months, and to keep us all occupied
who have you got lined up for next month?
Oh, I'll tell you in a minute. Okay. Big secret. Big secret. So
during our recording.
Yeah, Paul. Again, thank you very much. It really is appreciated.
Welcome.
And good to finally get you on here.
It was kind of a very rushed thing, but yeah.
Much appreciated.
Thank you very much.
You're very welcome.